Okay, welcome again everyone to G Squared Academy, where you know excellence is epitomized. We're continuing our learning, all right? And I've noticed that students have a very big difficulty with drawing graphs. If you're doing sciences, you must be able to draw graphs. Chemistry, physics, or biology. You're going to be doing graphs in math. And you're going to be doing graphs in other things as well. That's because graphs are generic things. It's a general thing. And one of the problems is that we don't know how to draw graphs and we don't know how to interpret graphs as students. So in this video, I'm going to show you first of all how to draw graphs and draw them properly, what your examiner will be looking for when you're looking at your graphs. What is my examiner looking for when I draw a graph? Where am I going to get my marks? All right, so I'm going to show you what your examiner will be looking for, how you should draw your graph, so on and so forth. In a later video, I'll then show you how to interpret graphical data. All right. And for the most part, we're just going to be looking at line graphs, not bar charts or anything like that, just line graphs, because those are the most popular graphs that we do in the sciences. So for those people who's first time to this channel, just hit that subscribe button, because you know you'll be getting good content, as I've been saying on this channel. You know, hit the post notifications as well, so that you will be notified as soon as I produce a video, or as soon as a video is uploaded, rather. All right, so let's get into it. Now, on the page, as you're seeing there, we're looking at the force. This is for physics now. This is supposed to be a C. This right here is supposed to be a C. So this is supposed to be force. Okay? So it's force in newtons. The physics people would understand that. And the extension. So basically what you have is, you have a spring, pretty much, and you apply weights to it. You put weights on it. And of course, we measure weights in newtons. So we put some weights on it and we see how far the spring extends. That's all that we're doing here. Okay. Now, when you're going to be drawing your graph now, you need to be able to determine what is your independent variable and what is your dependent variable. Okay, so we have force and extension. Remember, the force is the weight that you apply to the spring, and the extension is really how far the spring stretch. That's really all. So you ask yourself the question, is the force dependent on the extension, or is the extension dependent on the force? Exactly. The extension is dependent on the force. So since the extension is dependent, the extension will go on the y-axis. Okay, so we know where that one goes, and of course we would know where the force goes on the x-axis. All right, so that's pretty much it. You have the data in the table. You ask yourself the question based on the headings. What is dependent on what? Is the force dependent on the extension, or is the extension dependent on the force? The extension is dependent on the force. How far the string stretches is based on the weight that you put on the spring. Therefore, the extension is dependent on the force. All right, so now that you have found that out, it's time to actually start plotting the graph. Okay, so I'm just going to move this away over here for a while. I soon bring it back. Don't worry yourself. I soon bring it back, so don't worry yourself. So here's my graph paper. Now, it's a bit long, but the first thing you want to do when you're plotting your graph is draw your axes. Students nowadays draw graphs and there are no axes on the graph. That's pretty weird. All right, that's very, very strange, as a matter of fact. So I like to draw my axis at the edge of the paper. So you're going to draw your y-axis and you're going to draw your x-axis. Your y-axis is your your vertical axis. All right, the one that goes up like that. And then your x-axis is the horizontal axis. It goes that way. Okay, so because of the shot, I'm just going to draw it a little bit up further. So I'm now drawing my y-axis. See, I'm drawing it all the way up to the top, all the way up to the top, all the way down to the bottom. Okay, and then I'm going to draw my x-axis. All right, so I line it up and I'm drawing my x-axis. You'll notice here that I'm using a pencil, and I'm using a pencil because sometimes you're going to make lots of mistakes when you're doing these things, so it's best if you use a pencil. Further, you are marked for using a pencil. You need to use a pencil. So don't start using a pen. All right, and notice I'm using a ruler as well, and this ruler is clear, and I use a clear ruler because it helps me to see what I'm doing really. All right, so we're pushing on. After I've drawn my lines, the next thing I want to do is I want to label my axes. So I'm going to put on X right there. So I know exactly where my X is, and I'm just going to bring down this paper a little bit, and then I'm going to put my Y right there. Okay. So now you have your X and your Y axis. Yes, you're seeing that. Good. All right. Then what you want to do is you want to label your axes. What is on my X-axis? What is on my Y-axis? So now I'm going to bring back the paper. So we already did it. We said the extension is on the Y and the force is on the X. So then we're just going to put that on. Okay. So on the Y-axis, we have the force. So I'm going to write force. And I have to write the unit of force as well, which is newtons. So force in newtons. And then now I'm just going to turn this so we can write the unit on the X-axis and what's on the Y-axis and what's on the Y-axis as well. On the Y-axis, we have extension. Okay. How did we measure extension? It was in centimeters. All right. Now, guess what? You would have gotten about 3 marks already by simply drawing your axes and labeling it with units. Just for that. You see what I'm saying? So it makes sense that you do this thing. You would get marks just for doing that. All right. Now on to the title for the graph. I'm actually going to do the title before I even start plotting the graph. So how do you do your title? Well, generally speaking, we try to make sure our title is simple and it explains what's happening in the graph. So the title of your graph, and I'm going to bring down this paper a little bit more, begins with graph of. So it's graph of. Graph of what? Graph of what's on the Y-axis versus what's on the X-axis. So it's graph of extension of a spring. And in bracket you can put centimeters, which tells you the unit that we're measuring it in. Graph of extension of a spring in centimeters versus the force applied, and we measure that in newtons. Okay, so let's look at the title of our graph. Let's look at that now. There you go. Graph of extension of a spring in centimeters versus force applied in newtons. This title explains exactly what my graph is about. It explains exactly what it's about. And guess what? You get another mark for having a decent title, a title which explains what your graph is about. Okay, so now it's time for me to do my scale. I'm going to be doing the scale on the X-axis first, on the X-axis, which is our force. So let me grab my little book over here to see what were the values for the X-axis. Notice here that the values for the X-axis run from 0 to 10. 0 to 10. Now, a big thing about the graph is that the graph should fit about 75% of the paper. So it means that my scale needs to ensure that 75% of the paper is used. Okay? And you should try to make sure the value, your last value, the maximum value you have here, you go about 1 above it based on the increments you go up by. Okay, so notice we go up by 1 here. See, 1, 2, we go up by 1 all the way up to 10. So 1 above 10 based on the increments would be 11. So you try to go up to about 11 just to be safe with respect to your scale there. Okay, so now we're going to work out the numbering for this. We're going to work out the scale for the X-axis here. All right, so watch what we're going to do now. We want this line to be 0, as it is 0. Okay, and we want 10 to be somewhere over here, as far as possible over here. Now, plotting graphs is not a straight thing. It's not like you go one time and you get it. It doesn't work like that. Okay, practice makes better. But you still have to, it's a trial and error thing. You are going to use trial and error to get this thing. Okay, so I'm just going to show you how I'm going to work this out. So if this is 0 and this is 1, then this is going to be 2, 3, 4, 5, 6, 7, 8, 9, 10. This is where my 10 is. Basically, this 10, which is going to be here, is less than 2/3 of this scale. Less than 2/3. I need it to be about 75%. Therefore, using each one of these to be 1, going up by 1, is not going to work out for me. I need to change that. Okay, I need to change that. Now, you're told that your scale should be using easy number. You should go up by increments of some easy numbers, by 2s or by 1s, by 0.5s and those sort of things. Okay, just to make sure you can work out the middle numbers easily. Now, I don't need to do that here, and I'm going to show you why. I don't need to work out any points because I have no points to work out. There you go. All of these numbers are whole numbers from 0 to 10. All are whole numbers, so I don't need to work out any points. So my scale on this axis can then be in such a way that it doesn't go up by even or by regular numbers, so to speak, if that is the correct terminology for that. But anyway, watch this now. So instead of using this as 1, I'm going to make this 1. Now, for those people who are not sure what those values are, I'm going to take my ruler now and show you what we're looking at. I hope you can see it right there at the bottom. What you're looking at here is that from here to here is 1 centimeter. Okay? From here to here is 1 centimeter. And then from here to here is another centimeter. There to there is another centimeter. There to there. You get the gist. Okay, so therefore from here to here is 2 centimeters. So instead of going up by 1 centimeter, I'm going to go up by 2 centimeters and see if we can get 10 to be somewhere way over here. So let's try that now. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's not going to work. It's not going to work if I use 2 centimeters. When I used 1 centimeter, and let me bring it back down here. When I used 1 centimeter, right, my 10 is right here. This is where my 10 is. When I used 2 centimeters, I didn't even get to 10. So let us then try 1.5 centimeters. Let's try 1.5. Okay, and see what that looks like. Actually, let me put back the ruler so we can do the 1.5 centimeters neatly. Okay, so from here to here, that's 1.5 centimeters. So we're going to make this 1. Okay, 1, 2, 3, 2. 1, 2, 3, 3. 1, 2, 3, 4. 1, 2, 3, 5. 1, 2, 3, 6. 1, 2, 3, 7. 1, 2, 3, 8. 1, 2, 3, 9. 1, 2, 3, 10. There's 10, and then 1, 2, 3, 11. There you go. So you realize now using 1.5 centimeters to go by that value in terms of size of the axis, we get to 10 way over here. Okay? Remember, when we went up by 1 centimeter, 10 was right here. When we went up by 2 centimeters, 10 wasn't even on the scale. When we go by 1.5 now, it's even better. It's perfect. All right, so we are going to go up by 1.5 centimeters for 1 Newton. Okay, this is why you use a pencil. Notice I have markings here now. Now I need to erase these things because I can't have those on my graph. It's not going to look neat and tidy, and we need our graph to look neat and tidy. All right, so let's write down those numbers now because we now have it. So this is 0, and this is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There you go. Okay, good. Now we can write one aspect. No, so, okay. So now we have done that. We're doing good so far. Now we need to do it for the y-axis. All right. So let's draw back for our paper. Let's see where our numbers started and where they ended. So let's look at the numbers now. Our extension started at 0 and ended at 20. Okay, started at 0 and ended at 20. Now, notice here, that the values for our extension have some points. We have 0.1, we have 0.9, we have 0.2. It means, therefore, that when you're doing your y-axis scale, you want to be able to easily pinpoint 0.1. 1.1, 1.2, 3.5, 3.9, 4.7, 4.8. You follow what I'm saying? You want to be able to easily pinpoint that. So the scale you're going to use over here needs to be very good. Okay? And for you to be able to do that. But we're going to work it out the same way. Okay, so this is 0, of course. And you want 20 to be somewhere up here. 21. And of course, I said you should go probably above 1 above it. Notice we're really going up by, it's not regular, but we could go up to about 22 in terms of a guesstimate of where we should go to. Okay, it's above the maximum value. 22 is above the maximum value, as you can see there. All right, so let's see now what we need to do for this. Remember, it is trial and error. Okay. It's trial and error. So therefore, you have to try, make some errors, and then we get the thing going. All right. So we want to go up by that. Now, if we take our ruler again, and we put our ruler there. Yes. Let me just bring this down some more so you can get to see it a little bit clearer. Okay. So notice I'm putting my ruler there. All right. If we go up by 1 centimeter for 1, see? 0 to 1, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 20 is right here. Wow, that's amazing. 20 is right there. Do you see that? 20 is right there. 0, 20. Already we have it solved. 20 is right there. Okay, so what we are going to do, and then 22 is right there. All right, and of course, from here to here is more than half. That's even more than 75%. Okay, that is about 90% of the graph, which means you're doing extremely well. So on this axis, the y-axis, we're going to make each centimeter 1 centimeter. That sounds weird. 1 extension, which is 1 centimeter. Okay, so we're going to be doing that now. And you clearly see why we're doing that, because from 0 to 20 is all the way up here. Okay, and you then say to yourself, sir, but remember you said that we're going to have to find 0.1, 0.2, 0.3. But if you look here, you will notice that between 0 and 1 there are 10 lines. There are 10 lines. This line right here, which I hope you're able to see, is actually 0.5. And then between 0.5 and 0, there are 5 lines, which means that each of these lines are 0.1. So this little line right here is 0.1, 0.2, 0.3, 0.4, 0.5, and then 0.6, 0.7, 0.8, 0.9, 1. Okay? So that's 1. So each of those little lines represent 0.1. All right. So let us write in those numbers now. Okay? All right. So now I've written the numbers, as you can see there, from 0 to 22 all the way up there. Let me bring it down so you can see it. See there? All the way up to 22. Okay, this graph paper is a bit big, which is good, because the bigger it is, the better you can see the comparison between the two things. And having said that as well, I just want to pause here for a second to just say to you that your graph really is just comparing usually two things. I am comparing the extension of a spring to the force applied to the spring. Okay, I want to really see if I add weights and I increase the weights to the spring, what would happen to the spring? Does it get longer? Does it get shorter? Well, we don't expect it to get shorter, but I'm just saying. Okay, so we're trying to compare, or we want to see what would happen to an extension of a spring as we add a load weight. So your graphs, generally speaking, are really comparing two things, two factors, two variables that affect each other. Okay? All right, so now that we have done all of that, guys, let us now look at a thing called the scale. The scale. Okay, now this is the most difficult thing for children, but we have already done it. This is the most difficult thing for students. Sorry, not children, even though they're children. But anyway, because the scale is so difficult to do, but we have just done the scale, as you saw we did it a while ago. And you now need to write down the scale. Okay, why we need to write down the scale? Because it shows the increments we go up by on the x-axis and on the y-axis. Okay, how much do we go up by and what distance does that represent? So I'm going to write right here scale. Okay, this is important, and I underline it with, you should use a ruler. I'm just using my freehand right now. So and then I'm going to write x-axis. Okay, what increments do I go up by on the x-axis? To do this, I can't just pull it out of a hat. I need to take my ruler. Here's my ruler. Okay, now watch this now. When I put my ruler down right here, okay, what I notice is this. Let me carry it up a little bit more so you can see it. Very good. What I notice is this. What I notice is that for every 1.5 centimeters, it is 1 Newton. Let's look at it. Here's 1.5 centimeters, and that's 1. You see that? Then we go another 1.5 centimeters, that's 2. Then we go another 1.5 centimeters, that's 3. Then we go another 1.5 centimeters, that's 4. So it means that for every 1.5 centimeters, we have 1 Newton. And that's your scale. And that's what we're going to write down. So on your x-axis, we would write 1.5 centimeters is equal to 1 Newton. Great. There you go. All right. Now, the next thing we want to do is we want to write the scale for the y-axis. So let me turn my paper around so you can see it clearly. Okay, we're going to do the same thing again. How much do we go up by on this axis? How much do we go up by? So there's my ruler right beside it. Here is my 1 centimeter mark. See it right there? And that's 1. 0 to 1, that's 1. Okay, then we go to 2 centimeters. It's 2. So the difference between 2 and 1 is 1. Then we go to 3. From 2 to 3, from 2 to 3 is 1 centimeter. From 3 to 4 is 1 centimeter. From 4 to 5 is 1 centimeter. It means that we go up by 1 centimeter here, and for every centimeter, we have 1 centimeter of extension. You follow? Let me say it again. For every centimeter, you have 1 centimeter of extension. All right, for every centimeter on the graph, you have 1 centimeter of extension. And that's exactly what I'm going to write here, where I'm going to write y-axis. 1 centimeter is equal to 1 centimeter of extension. Okay, good. Wonderful. Now, guess what, ladies and gentlemen? Right? You have accumulated quite a bit of marks already for this graph. You have a title. You have your scale. Your axes are labeled with units. You have axes. All right? So you're doing very well. The next thing you need to do is you now need to plot your graph. Now, when you're plotting your graph, your examiner really likes when you use dots in circles or X's. That's what they like. So just give them what they like. All right? And that's what we're going to do now. So I need to find my table. Here is my table. And what does my table say? My table says, let me bring it down a little more. My table says at 0, my extension is 0, which is this point. 0 means 0, which is right there. Sorry, you did not see that. 0 means 0. Okay? Then it says at 1, my extension is 2.1. When I have a force of 1, my extension is 2.1. So I need to find 1. Oh, here's 1. So I now need to find 2.1. So I go up, and this is 2 right here. And then what is 2.1? This little line right here. The little line above 2 is 2.1. Okay? So I'm going to put a dot in a circle right there. Okay? So that's my 2.1. Remember I said that each of those lines are 0.1. All right? Then now, 2 corresponds to 3.9. 2 corresponds to 3.9. So I find 2 newtons, which is right here, and then I need to find 3. So I go up, oh, this is where 2 and 3 meet. So now I need to find 3.9. So then now each line is 0.1, so that's 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9. Oh, it is right here. Very good. Very good. Okay, and I'll do a third one just to make sure you're understanding clearly. So when I look back on my table, 3 matches up with 6.2. 3 matches with 6.2. If I add a force of 3 newtons, the spring extends 6.2 centimeters. So let me find 3. Here is 3 newtons right here. Okay, and I go up, and what are we looking for again? 6.2. So here is 6 and here is 3. They meet right here. Okay, this is where the two lines would intersect if I were to draw a line going that way and draw a line going upwards, because that's what you're really doing. You're drawing a line going upwards from 3 and drawing a line going across from 6, and that's 6 right there. So where 6.2, it's 2 lines above it, so that's 1, 2, and that's 6.2 right there. Very good. Very good. So that's 6.2 right there. All right. So then I'm just going to plot the rest of the graph. Okay. So now I've finished plotting my points. All right. Now what I need to do is this. I need to draw a trend line through my points. In other words, if my points are curved, I need to draw a curve. If my points look like they're straight in a straight line, I need to draw a best fit line. Okay, once you look at this, I think everyone could agree that this is a line of best fit because it looks like a straight line. My points look like a straight line. So I'm going to draw a line of best fit through my points. And some students feel that your line of best fit has to pass through all the points, but that's not necessarily true. And I want to point out here also, you notice I'm using a long ruler, because it's better if you do your graph with a long ruler. There you go. There you go. There's your graph. Oh my, wow. This is a nice graph, I must say. It looks very nice. Okay, it's big. It's bigly, according to some people. But just to make sure it looks a little bit neater now, I'm just going to do a few things. I'm going to underline my scale. You'll do this, yes? Just underline some things just to make sure your graph looks a little bit neater, more presentable. The aesthetics of your graph is nice. And I'm going to underline the title as well. All right, great. Underlining the title of the graph. Awesomeness. Okay, there you go. Good, good, good. So there you have it. There you have it. There you have it, ladies and gentlemen. What is your examiner now looking for on this graph? Your examiner is looking, does the student have their x-axis with units? Yes. Does the student have y-axis with units? Yes. Does the student have a title which explains the graph? Yes. With units as well. It doesn't have to have units, yes, but it's there as well. Does the student have a scale? Yes, they have a scale. Does the graph, are the points plotted properly? Yes, you could check that. Yes, they're plotted pointily. They're plotted properly. Sorry. Does the student have a line of best fit? Yes. How much do I get out of for this graph? 10 out of 10, because the graph is in very good condition. And I'm not just saying that because I did it. I'm saying it because we worked through it together. We worked through it. We did what was necessary. Our graph fits more than 75% of the paper, which tells you that your scale is good. If your graph fits more than 75% of the paper, you have a good scale. That's that general rule of thumb. Okay? And having said that, give this video a thumbs up. If you found this helpful, give it a thumbs up as well. Please like, share, subscribe to my channel, G Squared Academy, where excellence is epitomized. I hope you found this helpful. Thank you for watching, and all the best in your graph plotting.